All right. Welcome back, Physics 11, to another exciting episode of Mr. Wellsby Gives You Some Notes. So today we're going to be talking about free fall or acceleration due to gravity. Now this isn't really new. We've already learned about the big three equations last class, which I've conveniently posted on the right-hand side of the board over here. And we're going to be just kind of applying these same ideas to a familiar concept, which is falling down. So one thing to keep in mind is, in the absence of air friction, so often in physics we're going to kind of pretend that we live in this idealized world where air resistance doesn't exist. So in the absence of air friction, all objects fall with constant acceleration. So on Earth's surface, that's going to be, I'm going to put a negative sign there because it's going to be downwards, but it's 9.8 meters per second squared. So what this is really saying, 9.8 meters per second squared, is another way of saying 9.8 meters per second every second. Or in other words, if you're falling and there's no air resistance, every second that's progressing, you are falling at a rate of speed that is 9.8 meters per second squared faster. So when you first start falling, you're going 0. 1 second later, you'll be falling at 9.8 meters per second squared, 19.6, etc., etc. 29.4. You're just going to keep getting faster and faster. So let's try this problem out here. Again, you have your big three equations here on the right-hand side. So the question is, a student drops their homework down a wishing well. After 2.4 seconds, it hits the water at the bottom. So how deep is that well? See if you can pause the video and try that one out for yourself. Okay, if you're still stuck after you tried it, just remember to use the variables that we know. So we have d, v naught, v, a, t. See if you can identify which ones you know. Keep in mind, not every bit of information you're given in a problem is going to be represented as a number. So it looks here like the only number we have is 2.4 seconds, and that's going to be our time. But there are two more bits of information that are not listed right away. So or as a number anyways. So one of them is the fact that they dropped their homework. Now when you drop something, what that tells me is you're just letting it go. If you're letting it go, the initial velocity is going to be 0. So they didn't throw their homework down the wishing well, they just dropped it. So the initial velocity is going to be 0. And even though they don't say it, we do know the acceleration, which is going to be 9.8 meters per second squared. Or if we really want to be careful and get into good habits, I would call it negative 9.8 meters per second squared because it is falling downwards. So from that, we're trying to find out the answer of how deep the well is. This is the main question we're asking. So which of these formulas could we use that has d, v naught, a, and t? Well, there's really only the one that can be used to solve that, and that's the first equation right here. So let's try and solve it. We have d equals v naught t. Now keep in mind that v naught is 0. So for v naught t, it makes our life easy that we can just cross that out because 0 times anything is 0. Plus 1/2 times negative 9.8 times t squared, which is 2.4 seconds squared. So here's our formula here. If we plug this in, what we would find is d equals negative 28 meters. So negative 28 meters is our displacement. What that means is, remember, the displacement is final minus initial. In other words, it's asking, where did you end up compared to where you started? Well, that would make sense that it's a negative value because what we're saying is the book ended up 28 meters below where it started when you first dropped it. Now, this question here is a bit trickily worded, so it does say how deep is the well, and so you would refer to this as being a 28 meter depth well. So if you asked what this displacement was of the book, you'd say negative 28 meters, but in this case here, the answer should be 28 meters. But if this was a test, I would accept either answer. That's how deep the well is. Now for this next example, we've got a football kicked straight up in the air at an initial velocity of 15 meters per second, and we're trying to solve how high it goes. So if you want, please pause the video, think carefully about what those 5 variables are, the d, v naught, v, a, t, and see if you can figure out how to solve it. If not, pause the video in another few seconds and I'll give you a little clue in the meantime. So pause it now if you feel confident. Okay, if you're still here, then the clue that I would give you is what is the final velocity? So in this question here, we've got a ball that's going straight up in the air and it's going to get to some highest point. What is going to be the velocity at that highest point? So if you think you know the answer, pause it here and continue. If you're still struggling with this one, then keep in mind that the final velocity in this case is going to be 0. So when you throw the ball up, it starts at 15 meters per second, then it goes to 14, 13, 12, etc., 1 meter per second, and then finally it reaches 0 meters per second. That's the exact point when it's reached the highest point on its arc, and any time after that, it's going to start moving downwards with a negative velocity. So pause it if you haven't done it yet to try it out, and if you have, let's go for the answer now. So in this particular case, there are 5 variables. D is what we're trying to find out. That's our question. V naught is equal to 15. B is equal to 0. A is equal to negative 9.8. And T we don't know. So let's try and solve the D first of all. So in this case here, we've got these variables, D, V naught, V, and A. Which of these 3 formulas on the right can we use to solve that problem? Let's shift these down here. Which of these 3 is going to work for you here? Well, there's only one that involves all 4 of those variables, and that's equation number 3. So in this case here, let's try equation number 3 out, see what happens. V squared equals V naught squared plus 2AD. V naught is equal to 0, so that's easy. 0 equals V naught squared, which is 15 squared, which is 225, plus 2 times negative 9.8 times D. All right, so if we rearrange this, we have 225. I'm skipping a few steps here. I hope you don't mind. If you want to go through the algebra, feel free to pause it and try that out yourself. 2 times 9.8 is 19.6. So this would be on the other side of the equation. So we would have D equals 225 divided by 19.6. Actually, just in case there's some confusion, let's go through the whole algebra here. So we have 0 equals V naught squared plus 2AD. That would leave us negative 2AD equals V naught squared. I just subtracted 2AD from both sides. And this is where we have negative 2 times negative 9.8 times D equals V naught squared. These negatives are going to cancel out. So D equals 225, that V naught squared, divided by 2 times 9.8 equals 19.6. And that's going to give us a height of 11 meters. So I'm going to put that in here for our answer here. We've got the height that it reaches is 11 meters. So what is the total hang time? Now, what this refers to is the total time that the object was in the air. Now, for the time that it was in the air, we have 2 ways of solving this. You can solve, so option number 1 is you solve the halfway point. So when it reaches the peak, and then you multiply by 2. Okay, so if we look at this problem here, we could solve for t. That would be the time it takes to get to the top, and the time it takes to get to the top is going to be the same as the time it takes to get to the bottom. The other option is that we can solve the entire time all at once. Now for that, there's 2 things that you need to know, 2 important points. When an object lands from the same height it was thrown from, so lands from same height, oops, H-E-I-G-H-T, when it lands from the same height, meaning that you throw it off of the ground and then it comes back and lands back on the ground again. Whenever that happens, there's 2 things that are true. One is that our final velocity is just the negative of our initial velocity. So what this means is if you throw it up at 15 meters per second, when it lands, it's going to be at negative 15 meters per second. So this will be true only when it lands from the same height. And what's also true, maybe not really apparent right away, but that the total displacement is going to equal 0. So hopefully that makes sense. You're starting and finishing at the exact same point, and so therefore the total displacement will be 0, obviously. You haven't gone up or down overall from where you started. So let's try, the first one here, the solving the halfway point, you're already ready to do that. You've got the D, the V naught, the V, the A, and we can solve for the T. So we can use this one, for example, here and solve for T. But let's try doing it the entire trip, how long it takes to go all the way from the bottom up to the top and then back down to the bottom again. So in this case here, we know our V and we know our V naught. So our V naught equals 15. Our V is going to equal negative 15. A equals negative 9.8. E equals 0. And T is what we're trying to find out. So what formula can we use to solve this problem? Now, there's actually two that we could use, but one you wouldn't want to use. You could, but you wouldn't want to. You could use the first formula, but here's the problem. This is not 0 anymore. This V naught is not 0. So what that means is that you're going to get, if you try and solve for T in the first formula, you're going to get a quadratic equation. And you have to do the quadratic formula. That's a lot of work, but this one here you can use right away. So let's try that one out. So we're trying to solve for T, and so if V equals V naught plus AT, then V minus V naught equals AT, or T equals V minus V naught over A. In this case, we have negative 15 minus 15 divided by negative 9.8. These are all negatives, you can see, so they're going to cancel out. You have negative 30 over negative 9.8. Change those to positives, and we end up getting T equals 3.0 seconds. So if you solve the first way, what you would have gotten here is 1.5 seconds. You just have to remember to multiply that by 2. Because again, I guess I could say this, the T up equals T down. If it takes 2 seconds to get up, it's going to take, or 1.5 seconds to get up, it's going to take 1.5 seconds to get down. All right, and this is the last question. So it's a short set of notes today, but let's give this last question a try. So please pause the video here and give this question a shot. You have a student standing on the edge of a 45-meter high cliff. They throw their physics straight up in the air at 12 meters per second. How long does it take to come back to the same height? And if it falls all the way to the bottom, how fast is it traveling when it hits the ground? So give these a try and pause the video and come back when you're done. Okay, so here we go. I'm going to solve this. The first thing I'm going to do is I'm going to do my drawing. So I've got 45 meters, and I've got the homework going from here upwards at 12 meters per second. And then it's going to come back down to here for the first part, part C, and part D is when it hits all the way to the bottom of the ground. So let's try and solve part C. How long does it take to come back to the same height? Well, we can use our tip that we just learned from the previous question. So let's look at this. At this point, V naught was equal to 12, B is equal to negative 12, A is negative 9.8, and we're trying to solve for T. And so in this case here, we can solve for this just like we did in the question above. So we have T equals V minus V naught over A, which is going to be negative 12 minus 12 divided by negative 9.8, and that's going to give us 2.45 seconds. So this is our first answer here. Now, if it falls all the way to the bottom of the cliff, how fast is it traveling when it hits the ground? Let's again take the same approach. Let's see what we know. We know our V naught is equal to 12. Our final speed, this is what we're trying to find out. Our acceleration is going to be negative 9.8. We don't know the time, and do we know the distance? Well, yes, we do know the displacement. And what is the displacement going to be? Now, many of you are probably saying right now to yourselves, self, the answer is 45. But if you said that to yourself, you would be wrong in this case because we have to take into account the direction. And so in this case here, our displacement is going to be negative 45 meters, meaning that it ends up being 45 meters below, or negative, below where you started. It started at the top of the 45-meter cliff, it ended at the bottom of the 45-meter cliff. So now let's see what we can solve for. We have V naught, A, and D. So let's take a look at these three formulas again and see which one's going to work for us. Okay, let's see. We've got V naught, A, and D, and we're trying to solve for V. Well, there's really only one that's going to get us to the finish line, and that's this one right here. So let's give it a shot. V squared equals V naught squared plus 2AD. V squared we don't know, but we do know that this is going to be 12 squared. I'm just going to call that 144 plus 2 times, let's see, times negative 9.8 times the D, which is negative 45. And so when you calculate this out, you are going to get, let's find the answer here. So I've got 144 plus 2 times negative 9.8 times negative 45. And this gives us 1026. Now I'm going to take the square root of this answer here, and that's going to be 32. So what I have is V equals 32. Now, what is the problem that you're noticing, and what is the solution to this problem? So on the surface, it looks like V is equal to 32, meaning it has a value of positive 32. But that doesn't make much sense because that would tell us it's going upwards. So just remember, a general rule of thumb with a square root, the answer is always going to be plus or minus. So for example, if the square root of 9 is equal to plus or minus 3. Now keep in mind why that would be. If I square 3, I'm going to have 3 times 3 equals 9. If I square negative 3, I'm going to have negative 3 times negative 3. That's also going to be 9. So the square root of any value is going to be always plus or minus if we're really being careful and thoughtful about what we're saying. So in this case here, the velocity is plus or minus 32. Well, you have to choose which one makes more sense in this context. And so for us, the final velocity is going to be negative 32 meters per second. Again, this is one of those problems that on a test, if you put in 32 or negative 32, you're going to be right either way. And so I'm absolutely fine with the answer if you had 32 or negative 32. But if we're being a bit more careful, it would be negative 32. Anyways, thanks again for listening, and see you in class.